Blue is making good progress towards restoring its launch pad, but you won't recognize it when they're done. NASA considers sending a Mars rover to the moon, Rocket Lab makes a big purchase, and Zeppelin is making rocket parts for RFA. As always, we've got all that and more coming up this week in Spaceflight. NASA gave an update on its moon base program this week, and things are moving fast as the agency takes steps towards returning astronauts to the moon. Let's start with some new lunar lander contracts awarded this week. NASA previously announced the landers for its first 3 moon base missions, which sit inside of its Commercial Lunar Payload Services program, or CLPS. Those awards went to Blue Origin's Blue Moon Mark 1 lander named Endurance, Astrobotic's Griffin lander, and Intuitive Machines' third Nova C. This week, NASA handed out 4 more lander missions across 3 companies, each worth around $148 million. Astrobotic picked up 2 more missions using its Peregrine lander, Firefly Aerospace will send 1 more Blue Ghost lander, and Intuitive Machines will send a 5th Nova C. These missions are aiming to launch in late 2028, and each one delivers more than just science and payloads to the lunar surface. NASA says the learning and reliability built up through a faster cadence will also bring down risk for when astronauts finally arrive. The biggest surprise announcement was that the agency is seriously considering sending a Mars rover to the moon. NASA Administrator Jared Isaacman explained that, with excess mass and volume available on the early missions, the agency has been raiding the pantry for other payloads that could hitch a ride.
So a little bit of a Star Wars reference here. I think those that know our Mars rovers, Curiosity and Perseverance. Well, there is another, and the engineering development unit for it is called Promise. And I'd say we are thinking very hard right now about sending Promise to the moon.
The Polar Rover for Observation, Mapping, and In-Situ Exploration, or PROMISE for short, is a full-scale engineering twin of the Mars rover Perseverance that's lived at JPL's Mars yard since September of 2020. It's been used to test drilling, driving, and sampling maneuvers before the commands are ever transmitted to the real rover on Mars. NASA previously showed images of the rover in the Mars yard back in 2021, where it shared the garage with Curiosity's twin Maggie, or the Mars Automated Giant Gizmo for Integrated Engineering. At the time, NASA referred to the rover by the name Optimism. But why send an old Mars test rover to the moon? Other robotic vehicles being sent to the lunar surface right now use solar panels for power. This can be a real problem near the lunar South Pole, where the sun barely climbs above the horizon and entire craters sit in permanent shadow. Curiosity and Perseverance, however, both run on a radioisotope thermoelectric generator, or RTG. This is a nuclear power source that uses heat from radioactive decay to generate electricity. It doesn't care whether the sun's out, so Promise wouldn't have that limitation, and the rover could work through the 2-week lunar night that most solar-based hardware struggles to survive through. Being able to stay in shadowed craters would also give it a unique set of capabilities even beyond NASA's revived Viper rover, which will also be sent to prospect the lunar South Pole.
It gives us a lot of options to be working in those permanently shaded regions a lot longer than Viper would survive. So great capability, something that taxpayers already invested into. And we outfit it a little bit differently, put some different instruments on it, and it's going to be a highly capable vehicle for the South Pole moon, and we can get it there fast.
RTG-powered rovers have a proven track record and have certainly over-delivered. Curiosity landed on Mars in August of 2012 for what was originally only a 2-year mission, and it's still driving almost 14 years later. Perseverance touched down in February of 2021 with a primary mission of just 1 Mars year, which is about 687 Earth days, and it's also still going strong over 5 years later. If Promise inherits even just a fraction of that endurance, it's a serious bonus for the moon. Now, as exciting as this would all be, NASA is still studying this idea, so it's not a committed mission just yet. As the agency points out, it is in the business of achieving the near impossible, though, so they might just make it happen. And speaking of endurance, Blue Origin's hardware is stepping even closer to launch. The company's Blue Moon Mark 1 lander, named Endurance, just wrapped a series of shock tests. These simulate the environment when it will separate from its ride aboard New Glenn. With more than 20 accelerometers positioned around the lander, Blue reports that all components successfully exceeded their survivability requirements. Assembly is nearly complete now, with the engine and the cryogenic propellant yet to be added. The lander will next undergo full vehicle separation testing. Following New Glenn's anomaly on the pad recently, NASA has been working closely with Blue Origin, which is determined to return to flight before the end of the year. Put a pin in that for later. Plan A is still to fly the lander aboard New Glenn, as Isaacman explained.
Some time has gone by since the anomaly right now, and Blue Origin's response to the situation is almost beyond impressive. And that's not just a NASA assessment. I mean, you've had, representatives from the DOW Space Force that's out there, and seeing the amount of resources they've been able to kind of, muster to the problem, how quickly they've already started cleaning things up, how, the progress they are making on the investigation. So Plan A is very much still to launch the Mark 1s on New Glenn. And we have time. They are very committed to getting back in the business of launching New Glenn before the end of the year.
Hardware for other moon-based lander missions is also making steady progress towards the finish line. Astrobotic's Griffin lander is almost ready to ship to JPL for its own environmental testing. These tests will simulate the vacuum of space and the wild temperature swings of a real mission to make sure that the lander structure and systems hold together before it ever leaves the ground. After that, it'll receive its engine and meet its payload, the Flip Rover, which we've talked about in recent episodes. Last week, Intuitive Machines installed the top deck on its latest Nova C lander, Trinity, ahead of its IM-3 mission. The lander's now moving into full vehicle integration ahead of its Hotfire campaign. With 3 more Nova C landers to deliver, and counting, the company is scaling up its manufacturing processes to support high-volume production. And finally, in our lander updates, Firefly Aerospace has acquired a company called SpaceNG this week. This is a small Colorado-based outfit building AI-powered vision navigation, the kind of tech that helps a lander identify hazards and steer around them during descent. SpaceNG's tech already flew on Firefly's first Blue Ghost mission to the moon's Mare Crisium, helping it to avoid hazardous terrain in real time. Its co-founder, Ethan Rubley, is joining Firefly as chief engineer of software. With Firefly ramping up more lunar deliveries, bringing the company's navigation expertise in-house will enable Firefly to sharpen every landing in the future. With momentum on the moon base program continuing at pace, NASA has promised updates each month, so we'll bring you more information as it reaches us. The first robotic landings could be touching down before the year is out, so there's a lot to look forward to. Okay, so remember a few minutes ago when I said that Blue is working on repairing its launch pad? Well, this week, CEO Dave Limp updated everyone about their progress and future plans, and it seems to be going well. He still believes that they'll be flying again by the end of the year. To quickly recap what happened, on May 28th, a static fire test ahead of New Glenn's 4th flight ended in disaster. Fortunately, no one was injured, but the rocket was gone, and it took away most of the pad with it. Blue's still chewing through all the analysis to get to the cause of the anomaly, but they have already concluded that it happened somewhere in the aft section of the rocket, and that also corresponds with what we saw in our footage. It's where the explosion began, so no surprises there. Blue is now working through a 5-step plan to get the pad back into shape, and the first 2 steps have already been checked off. So what's the plan? Well, the first phase was to secure the site, which they have completed. Then Blue went into site recovery and cleanup, also complete. Phase 3 is ConOps design and major repairs, which they're currently working on. Now we'll get into this in a bit more detail, but let's quickly just finish the plan first. The last 2 phases are systems integration, and finally, flight readiness. Needless to say, they'll need to do some work before they can get into these steps. Now, as mentioned, they are now working on ConOps design and major repairs. ConOps is an abbreviation for Concept of Operations, or how the launch pad and its systems work. Blue's planning to change all of that. They're not building the same launch pad as before. Instead, they're changing how New Glenn is integrated and brought to the launch pad. Previously, the whole rocket was horizontally integrated. Now, they'll only mate the 2 stages that way. But unlike previous stacks, they won't use a big transporter erector that puts the rocket vertical at the launch pad. Instead, they'll put the rocket on a simpler transporter to roll it to the pad, and then use a crane to lift it vertical and place it on the pad. Similar to what they do after recovering a booster, but in reverse, and with a second stage attached. Then, the tower will extend a pair of access platforms, and the payload, encapsulated in its fairing, will be placed on top. Speaking of the tower, it will need some modifications. First, there's the access platforms that I just mentioned, but the upgraded tower will also host all the umbilicals that connect to New Glenn ahead of launch and contain all the propellant lines and the electrical connections. You won't get the rocket off the ground without them. Blue's videos show that New Glenn will be rotated by 90 degrees compared to the previous pad design, which is most likely to make these connections easier. From the video and renderings, it also looks like they plan to attach more stuff to the tower, but we're not sure what it's used for for, and considering that some generative AI seems to have been involved in the creation of these images, not all of that may actually serve a purpose. We'll have to wait for the real deal, I guess, and work is already on its way. Max, Dee, and Julia had a look at Launch Complex 36 from above this week, and Blue has turned into a forest of cranes, all helping with the cleanup and rebuild. At the time of the flyover, one of the cranes was attached to the top of the tower. Just after our team landed, our Space Coast Live cameras were able to spot this module being removed. Earlier, Dave Limp tweeted that they'll start pulling down the tower segment by segment and modify the pieces before putting it all back together again. It seems like they've actually started that process now. Hopefully it'll all be smooth sailing from here on out, and they'll manage to get to phase 5 of their plan before the end of the year. Now, there is a lot more to see in our aerial footage other than just cranes, but don't worry, we've got an entire Space Coast update coming up next week, analyzing everything that's going on at the Cape in detail. So the subscribe button may come in handy to stay on top of all of that. And if you want something to watch in the meantime, well, first off, there's much more space news left in this episode, but when you're done with that, Ryan did a full analysis of Dave Limp's announcement over on our Breaking Space channel. Rocket Lab CEO Peter Beck put on his big announcement jacket this week for a major company update. Yep, they made a whole video bursting at the seams with jokes about his jacket. But we're a spaceflight channel, so let's focus on the actual announcement, huh? Rocket Lab is buying satellite communications provider Iridium for the equivalent of $8 billion in stock and cash. If you're a regular viewer, you'll know that Rocket Lab is no stranger to acquisitions. The rocket builder has bought up so many spaceflight companies that they're now active in pretty much every area of spaceflight. So why is Iridium such a big deal? Well, for a long time, Peter Beck has hinted that he wants Rocket Lab to develop its own satellite constellation and enter the space applications market. Now they're taking a shortcut to do exactly that. And it kind of makes sense. SpaceX has all but disrupted the satellite communications market with Starlink, which is now a bit of a cash cow for the company. And with other mega constellations like Amazon Leo coming online, there seems to be enough space in the market for multiple players. Now, of course, Iridium already has its own constellation up in space, but with only 66 active satellites and 14 spares in orbit, there's nothing mega about it. That doesn't seem to be a problem, though, as Rocket Lab isn't just interested in the satellites. After all, they are a satellite builder already. Beck says that Rocket Lab gets 2 more things out of the deal. First, Iridium already has millions of customers and is operating a profitable business. No need to sink money into a constellation that has yet to find a customer base. And second, Iridium has spectrum, or the rights to use certain radio frequencies. This is perhaps even more valuable than anything else that Iridium has to offer. For instance, just last year, SpaceX handed over $17 billion to EchoStar to acquire spectrum for licenses for Starlink. Iridium's existing constellation is still useful, though. They've already done the hard work to get it designed and operational, so Rocket Lab can skip these steps. But they don't want to keep it at that. Once the transaction completes next year, Rocket Lab plans to build upon the constellation to grow the business even further. Now, of course, we don't know what that future will look like, but a quick look at Rocket Lab's own product lineup might give us some hints. Last year, they unveiled a satellite platform optimized for mega constellations called Flatellite in a nod to its stackable design. Once the company finally gets Neutron off the ground, they'll have all the technology and expertise in-house to grow out a much larger constellation with capabilities far beyond Iridium's current network. Although Neutron isn't flying just yet, so it might still take a while. We wouldn't mind an update about that, though. Now we'll take a look at some other stories across space, starting with NASA opening applications for a Moon and Mars exploration mission, except the crew won't even leave the parking lot at the Johnson Space Center. For the last few years, NASA's Crew Health and Performance Exploration Analog, or CHPEA program, has simulated life on the Martian surface. The goal is to learn how astronauts cope, both physically and mentally, with the isolation, confined space, and communication delays of a real Mars mission before anyone actually goes. 4 volunteers at a time have spent a year inside Mars Dune Alpha, a 3D printed habitat housed inside a hangar at the Johnson Space Center in Houston. A second CHPEA crew is in there right now and will complete their mission on October 31st. This new program builds on that, but it adds something CHPEA had never had before, a simulated journey to get there. 4 new volunteers will first live inside the habitat that NASA previously used for its Human Exploration Research Analog, or HERA program. This will stand in as their transit spacecraft, after which they'll move into the CLPS surface habitat for the simulated planetary stay. All in, that's about 12 months across both habitats, plus 2 months of training beforehand. Unlike CLPS, this mission is explicitly designed to inform both Mars planning and NASA's moon base program. Volunteers will assess and validate hardware and technologies, protocols, and other systems that are critical to long-duration missions. The mission is targeted to begin no earlier than August of next year, and NASA's already accepting applications. So if you've got a STEM degree and don't mind some confinement, NASA wants to hear from you. NASA has tested a crucial part to enable on-orbit refueling. In space, you can't just drop a hose in a tank and start pumping. Several factors make it a lot more challenging, not the least of which is the propellant temperature. Many spacecraft nowadays use cryogenic propellant combinations like liquid hydrogen or liquid methane paired with liquid oxygen. This stuff needs to stay at frigid cryogenic temperatures to stay liquid, and at those temperatures, the hardware and seals to contain them behave very differently than at room temperature. So Aerojet Rocketdyne developed a special coupler to connect the lines between a tanker and the spacecraft in need of a top-up. The company was awarded the NASA contract in April of 2023 before it was absorbed into L3 Recently, NASA and L3 joined forces to test the coupler at NASA's Marshall Spaceflight Center. But they didn't just flow liquid nitrogen through the part to test it at cryogenic temperatures. They also tried to push the system to its limit, including coupling the device after a misaligned docking, which it's designed to cope with to some extent. There's still a lot of work to be done before this device can be used in space, but it's great to see NASA and its partners work on these challenges that will one day become as mundane as filling up your car. Rocket Factory Augsburg has yet to fly its RFA-1 rocket, but the German company is already building the next one. RFA-1 is currently being prepared at Saxavord Spaceport in Scotland. It has a UK launch license and is working towards a maiden launch in the third quarter of this year. Standing 36 meters tall, 9 3D printed Helix engines will power the first stage of the rocket, which can carry around 500 kilograms to low Earth orbit. Behind the scenes, though, RFA has been building the rocket's Block 2 configuration, and this week the company showed off a major piece of it. This is the first stage propellant tank built by supplier Zeppelin. Yes, the airship company. They're still around building airships and apparently rocket parts too. It's bigger and it needs to be. Block 2 will stand another 9 meters taller at 45 meters with increased propellant tanks. It'll fly with upgraded Helix 2 staged combustion engines, each delivering roughly double the thrust of the current design. The improved rocket will carry up to 3 times the payload mass to low Earth orbit, around 1.5 tons in expendable format. Wait, expendable? Unlike Block 1, the first stage is planned to be reusable. RFA says that this tank marks its first concrete step toward recovering and reusing that first stage. And this isn't just an engineering flex. RFA stands to receive up to 169 million euros through the European Space Agency's Launcher Challenge with some demanding milestones. Block 1 needs a successful flight by the end of 2027, with Block 2 following by the end of 2028. In the meantime, we'll keep our eye on launchpad Fredo at Saxavord in the coming months as RFA moves towards the first vertical orbital launch from UK soil. This week, Firefly Aerospace and SSC Space cleared another milestone towards Europe's first orbital rocket launch from mainland Europe's Arctic spaceport. The Srange Space Center in northern Sweden has been operating since 1966, launching hundreds of sounding rockets and stratospheric balloons over the years. To date, its rocket flights have all been suborbital. Despite cutting the ribbon on an orbital launch pad back in 2023, plans for South Korea's Perigee Aerospace to launch its Blue Whale 1 from the site have slipped, and Srange has yet to send anything to orbit. But Firefly and SSC are working to change that, and this week the two companies confirmed that construction is entering its final phase at Launch Complex 3C. Key infrastructure includes a launch control center, payload processing, and vehicle integration buildings. The work is backed by a new regulatory agreement between the Swedish Space Agency and the U.S. Federal Aviation Administration. This builds upon a technology safeguards deal allowing American rockets to fly from Swedish soil, with a first launch planned for 2028. The rocket, taking that first flight, will be Firefly's 2-stage Alpha. The vehicle last flew back in March, testing and validating components of its new Block 2 configuration during the Stairway to 7 mission. Alpha's next launch in the full Block 2 design could be as early as this September, when we'll see the taller and more capable version take to the skies for the first time. This will be the first of at least 4 missions for the Open Cosmos broadband constellation in low Earth orbit. Srange may not be ready for orbital missions quite yet, but now we'll take a look at how some of the world's other active launch pads were used in this week's Space Traffic Report from Next Spaceflight. SpaceX launched 3 times this week. For one of the missions, Falcon 9 lifted off from Cape Canaveral to carry the SXM-11 mission for satellite radio company SiriusXM. Falcon delivered the spacecraft into a geostationary transfer orbit. The other 2 Falcon 9 missions of the week used SpaceX's launch pad at California's Vandenberg Space Force Base. Both missions carried a batch of Starlinks, adding a total of 48 satellites to the constellation. Another batch of internet satellites started their journey to space. Atlas V carried 29 Amazon LEO satellites into orbit. This was the final launch for the rocket's most powerful 551 configuration. The 551 designation refers to 5 solid boosters, a 5-meter fairing, and a single RL-10 upper stage engine. Now, there are a few more Atlas Vs left, but they're all reserved for Boeing's Starliner capsule. When or even if these will fly is anyone's guess, considering the state of Starliner. Over in China, a Changzheng 4B lifted off from Zhochuan to loft the Haiyang 2E satellite. From this sun-synchronous orbit, the spacecraft will study the oceans, measure marine winds and surface temperature to help improve forecast for the prevention of natural disasters. 2 astronauts also went for a walk outside the International Space Station this week. NASA's Chris Williams and Jessica Meir donned their spacesuits on June 30th and exited the station's Quest airlock. During this 7-hour and 20-minute extravehicular activity, the pair replaced a wrist joint on the station's Canadarm2 robotic arm, which broke during operations on May 27th. Teams on the ground will inspect the faulty joint and potentially refurbish it for future use in space. This was Williams' 2nd spacewalk and Meir's 5th, and the 280th total conducted for the ISS. And that's a wrap on the first half of 2026. In total, we've had 154 launches so far this year, with 6 failures. Continuing at this current pace, we should end with around 308 launches this year, slightly behind last year's 324. June added 28 launches to these numbers, with 14 from Falcon 9 alone, and 10 from China's rocket lineup. Closing out the week, we had another potential final flight. After a few scrubs for weather and vehicle issues, the air-launched Pegasus XL finally launched carrying Catalyst Link spacecraft. The vehicle will meet up in space with NASA's Neil Gehrels Swift Observatory to boost it back to its original 600-kilometer orbit to save the spacecraft from its imminent demise. While not confirmed that this will be the final Pegasus XL launch, the rocket is the last one manufactured, and there hasn't been a lot of demand for the rocket recently, so it seems unlikely that Northrop Grumman will ever have to make another one. A rocket we will see many more launches of is, of course, Falcon 9, for which SpaceX has 3 launches planned next week. One of the missions, lifting off from Vandenberg, will launch 81 payloads for the company's Transporter Small Rideshare program. The other 2 missions will loft more Starlink satellites from SpaceX's launch pad at the Cape. The second of these, set for July 9th, is scheduled to use booster B-1067 on a record-setting 36th flight, pushing Falcon 9's reuse even further. Up in space, Japan's Hayabusa 2 mission is set to fly past asteroid Torifune on July 5th. The spacecraft, which collected material from asteroid Yugu and delivered it into the hands of scientists by late 2020, is now on an extended mission to explore more asteroids. This week, that mission will bring the spacecraft about a kilometer from Torifune while traveling at 5 kilometers per second. Talk about a flash visit. We may also see some launches from China next week, with a Changzheng 6A scheduled from Taiwan and a Changzheng 8A from Wenchang. We might even see the first flight of the Changzheng 10B lifting off from Wenchang later in the week. This is the reusable, cargo-optimized version of the rocket for China's moon program. Details for these missions are still up in the air, though, so keep an eye on Next Spaceflight to make sure that you won't miss it. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.